Maybe we can start. I can start talking about IFSA and the first presentation. And hello, it's a great pleasure to have all of you here to this conference because it's today it's the World Environment Day, and this is very important to talk about all these problems and these things that we pass in our forestry, in our forests, and it's important also to talk about the tipping point that Natalia will talk. And so for this week of conference that we made for the visit of Cacique in the next Saturday, we start with the presentation of Bruno Ferri and Tuesday about ecology and tropical forestry. Today we have the presentation of Natalia from Universidade de São Paulo of the tipping point and traditional people of Amazon forest. And in the next week, 10 June, Tuesday, we have the presentation of Stefan about the impacts of climate change. And then all these presentations are organized by IFSA, which is an International Forest Student Association, and this association can have contact with all the forest students of the world and make a lot of good exchange and contact. So we can start with the presentation. If you want, Natalia, you can start presentation yourself.
Thank you, Felipe. Hi, everyone. Good afternoon, good evening to all. I'm Natalia Nascimento. I'm professor at the University of São Paulo. And also, I'm an Amazonian woman. I'm from the Amazon, and I work with forest degradation, deforestation, and more recently, forest restoration for more than 2 decades. So today, I will share with you some information and some reflections you can talking about tipping point the Amazon. I will share my screen. So Felipe, thank you, IFSA, for the invitation in this day that is so important day to us, the World Environmental Day. So today I will talk about avoiding the Amazon tipping point and talking about the importance of biodiversity and traditional people. I don't know if you want to make question during my presentation. I don't know if you can have a conversation or a speech before. So, Natalia, what is a tipping point? A tipping point is today a very common and famous concept in Brazil because we are talking about Amazon deforestation, Amazon forest degradation, climate change every day. So a tipping point is for us in Brazil a very common concept today because we are talking about it every day. So, but what is this? A tipping point, the concept says that a stress value from which the system begins to change in an accelerated way by positive feedback mechanism. But what it means? A tipping point is a threshold, a value, where continuous pressure, continuous stress, disturbing in an ecosystem push this ecosystem to a limit where this ecosystem can change this landscape, its structure, its functioning. So this tipping point is like a threshold where you have another place, another landscape, another ecosystem, sorry. So you have to understand better this concept. You need to understand some concepts that are interligated with tipping point. One is the ecosystem resilience. Resilience is another concept that is very famous today because every day we are talking about, or someone is talking about to us, that you need to be more resilient, you need to overcome problems, etc. It's the same, it's very similar to the ecosystem resilience. So the concept says to us that ecosystem resilience is defined as the amount of disruption that a system can absorb and still remain in the same state, along with its ability to reorganize and renew itself. That is, I don't know if you can see my point. But here you have a landscape, for example, ecosystem that every year, every day, the human are pressure this functioning, this structure of this ecosystem. So you are testing the resilience of this forest. And every time we put fire or increase deforestation or change the temperature, for example, we are testing the forest resilience. Another concept, important concept, is the positive feedback. Because in the concept of tipping point, we every time we will see this positive feedback concept. Here, positive is not a good word, is not a positive word. Actually, positive feedback is a process that adds some pressure, some disturb in the ecosystem. So a positive feedback or a reinforcing feedback are mechanisms that amplify the degradation of the Amazon rainforest in this case, accelerating its transition to a non-forest state. These feedbacks arise from interactions between deforestation, climate change, local disturbances, and create a vicious cycle. So I was talking about the pressure that we are working here in this landscape, in this ecosystem. So what are these elements? Are deforestation, today, you are talking more than deforestation, you are talking about forest degradation, the aggregated wildfires, forest fragmentation, edge effects, illegal extraction of wood, of natural resources, and the increase in the temperature. So all this pressure here is considered positive feedback. So they are working in this scenario, in this context, and force the forest to achieve this tipping point. So, okay, but what is the problem? Because every day you are listening that you have environmental problems, environment impacts. So what is the difference to a tipping point? The difference is when you have a problem, environmental problems such as a pollution, etc., you can work to try to recover that ecosystem. The problem of a tipping point is that you can't come back. This after you cross the tipping point, we can't recover the ecosystem as it was before. So you have a new state with a new structure of forest, a new climate, a new soil, a new composition of species of this forest. So here we achieve another concept that is critical transition. So we're talking about resilience, We talked about positive feedbacks. All this process here can push the forest to a tipping point. There is the moment that the forest crossed line and can to adopt a new landscape, a new functioning, a new structure. So you have a critical transition. What is this critical transition? A critical transition occurs when the system passes to point of non-return, the tipping point, and shifts to alternate state of equilibrium. Because the new state of equilibrium, the tipping point is so important to understand because you can work here to try to recuperate this landscape to this one. Here you have a new state, and this new state will be in equilibrium. So in this scenario, we only can adapt. So you have today many tipping points, many risks of tipping point across the world. In this study, you have mapped some tipping points and considering the change in the temperature. So you can see here in the legend some class of transition in the temperature. So you have a first one, a class transition below 2 Celsius degree, in the middle 2 to 4 Celsius degree, and another one above 4 Celsius degree. Please note that you have this cycle. Here, there is the most vulnerable places, a place that are in colder ecosystem, such as the poles, the ice sheets, etc., and the coral reefs. These ecosystems are so vulnerable to the climate change. And in this map, we are only considering the temperature. So today, we're talking about this one, the Amazon rainforest dieback, that is here in the middle, in a threshold where you have the change in temperature between 2 to 4 Celsius degree. So I will base my presentation in this study. My team published this study last year, and we deal with the critical transition, that concept that I said to you before, and you try to understand, identify the drives of this transition, the drives that push the Amazon to a tipping point, and where that can happen. So this paper was one of responsible for tipping point. Is a very common concept today in Brazil because we have many impacts in the media, social media, etc. So let's go. So to understand this paper, you need to understand this very important and intelligent resilience mechanism that the Amazon forest has. So you have two very important elements. There are evapotranspiration and moisture flow. We know today that part of the rain, the humidity that arrives in the Amazon, comes from the ocean. But another part of the rain produced in the region, the healthy part to be exactly, is produced for the forest itself. So you have this very important moisture flow happens here. with evapotranspiration, uh, some trees with a so deep root absorbing water from the deep soil and evapotranspirating this. And most part of this rain goes to the another place in Brazil, such as São Paulo state where I live, but as well to other country in the South America, such as Colombia, Ecuador, Peru, and Bolivia. Okay, so this is very important to understand this process, because if these mechanisms are so important to forest resilience, if you have intense drought or changes in the dry season or changes in the rainfall pattern, you can affect this resilience mechanism. This is very important to understand in this moment. And the cascade effect of this, because if you don't have rain produced in the Amazon, you have a problem in other places in the South America. So this moisture flow was based as form with flying river. Maybe you should know what is fly river, but it's like an invisible river that uh, goes to the another place of South America with rain. So in São Paulo, for example, we believe that half of part of the rain in São Paulo comes from the Amazon. So for us, this is very, very important. So consider this, we selected 5 drivers of water stress. So 5 drivers that interferes in this process, in this mechanism. So the first one is the global warming. You define it as critical threshold 2 Celsius degree. If you maybe you remember that 5 years ago when you created the Paris Agreement, the first number that was thought is this 2 Celsius degree. But scientists said that, okay, but 2 Celsius degree of limit is very bad for climate, for biodiversity, for human lives. So they created a safe boundary. There is the 1.5 Celsius degree. There is the goals of Paris Agreement. So we select this one, this value, based in literature with low confidence. The second one is annual rainfall. So this is very important to us because you have a critical threshold, and I will detail this in next slide. But you have a difference in the quantity of rainfall, the annual rainfall here, because if you have less than this value, you can have another landscape that is not a evergreen forest. So consider this is very important. The rainfall seasonality intensity, because as I said to you before, in the Amazon you have some trees that they have very deep root, and so when you have the dry season, this deep root can absorb water from the soil and maintaining the keep the process of evapotranspiration working. So you have the dry season length. There is very similar with this one because the difference is not the intensity but the extension of the dry season. So if you have an ecosystem that the trees has a process that in the period of the year with dry season, these trees use it to absorb this water in evapotranspiration. If you have this dry season more extended, you can have problem with the water in the soil. And this tree is incapable to make the evapotranspiration. This is a drive of forest dieback. And the last one is the accumulated deforestation. So some models are say that if you achieve 20% of deforestation in the Amazon base, you have the tipping point, but we define it as the safe boundary, 10% of deforested. So today you have uh, 18% of deforestation of the Amazon base. So we are reaching this threshold. So basically, you have a global warming acting in this local, in this region. So this global warming influence the regional rainfall conditions. So these regional conditions it has a direct influence interaction with accumulated deforestation. So you have a cycle here, and this cycle feed this another cycle that is water stress and forest loss, water stress and forest loss. So this is positive feedback to the tipping point. So in this study, we mapped some drivers of this tipping point. So in the letter A map, you can see the slope of temperature slope. So you can see a change here in the middle of the Amazon. And this limit in the east of the Amazon, this is a very vulnerable area, because in this area you have, I talked about it before after, but here you have I cotton is a limit with interaction between two biomes, the Amazon and the Brazilian savanna or cerrado. So the forest here is so vulnerable, and you have the problem that this area is the area called arc of deforestation, or deforestation arc, is where deforestation historically have been concentrated here. So map letter B, you have the map of forest stable and B stable forest. So I will explain this. And here in letter C, you have the number of extreme drought events. So please note that you have shape here, so with head dark, is very close to the slope of temperature. So are a very vulnerable area for tipping point, considering climatic aspects. And then you have the map of fire and roads. We choose to choose roads because the most part of deforestation in the Amazon are around these roads. So please note that you have here in the limits of the Amazon biome concentration of the roads and the fires. So to try to discount so bad elements, we considered indigenous territories and protected areas. So if you see the map letter F, you can see that areas where you have protected areas and indigenous land here in this map are the blue areas. And where you have a more impact of climate change and deforestation are more red areas. So they have more a higher tipping point potential. So, but let's try to explain what is this be stable forest and stable forest. So we consider that you have a mean annual rainfall and a percentage of tree cover. You have here in the orange, green, and blue class. The first one is area of savanna, stable savanna. So in savannas, it's very common, for example, a low mean rainfall quantity, so between 0 to 1,000 millimeters per year, and very low tree cover percentage. So this is a very common landscape ecosystem of savanna, and it's okay. It's a stable landscape, stable ecosystem. In blue, we have a very high mean annual rainfall, so between 1,008 millimeters per year to more than 4,000 millimeters per year. And with high forest cover percentage. So here in this part, you have forest, evergreen forest is stable, and it's okay. But between these two classes, you have areas of B stable areas, forest. So in this place, you have 1,000 to 1,800 millimeters per year of rain. And you have two different tree cover landscape percentage. So something between 10 to 30% of forest tree cover. That is very similar to the savanna. And another reality that shows us that in this situation, you can have a high tree cover percentage around 70 to 90% of tree cover. So in this situation here, you can have savanna or evergreen forest. This is very vulnerable situation because the transition between evergreen or savanna is very easy. And if you look that in the map, you have be stable forest here. In the limits of the biome Amazon, the limits that you have the interaction between Amazon and Brazilian savanna, and in the place where you have the arc of deforestation. So we are talking a very, very vulnerable place. So to resume, forests, be stable forests are forests that can exist stably in two different states under the same general climatic and environmental conditions. So here you have some important cities in the Amazon, such as Paragominas and Parauapebas. There are cities with huge importance to mine and pastures and agribusiness, and are in a situation where you can have a tipping point. So, a tipping point, when you achieve this tipping point and you go to a critical transition. This critical transition, what can be? So you have three options of ecosystem, alternative ecosystem. The first one is the white sand savanna. You have disturbances that allow to achieve this landscape. There is extreme droughts and fires. When you have these disturbances, you can feed this feedback. So you have a low tree cover that feed fires that contributed to soil erosion, that contributed to the seed limitation. So you have a cycle here. And this is an example of a white sand savanna. So the another option is the degraded open canopy that can be caused by the warming, by stability, extreme droughts, and fires. So when you have these disturbances working together, you have the low tree cover that uh, feed fires, that influences soil erosion again, that influence the seed limitation, that facilitates alien grasses, and you live in this landscape. So this is an example of a degraded open canopy. So the third one is the degraded forest. So you have warming, extreme droughts, deforestation, and fires acting here in this landscape. So you have a degraded forest that feed more deforestation, that are associated to fires that limit the seed and helps the opportunistic plants, and you live in this cycle. So you have these three options. Today, you avoid using the term savanization because the Brazilian savanna is considered a hotspot of biodiversity, and it's a global hotspot of biodiversity. So, for the scientists that work in the Brazilian savanna, they asked to us to change the term of savanization because savanna is not a bad thing, but you need to advance in this new classification. But today we use these three examples of alternative ecosystem. So this is the map, the resulted of your work. There is a map of potential for ecosystem transition. You have tipping point potential from -1 to 4, and it represents the possibility of forest transition to alternative structural compositional state. That is the ecosystem that I showed before, and across the Amazon biome by the year to 2050, inferred from compounds disturbance. So this is on map. I highlighted here three capitals of Amazon. They are in a very bad situation for all scenarios. There is Belém, the place where we have the COP30 next November. Manaus, the capital of Amazonas, Porto Velho, capital of Rondônia. And I highlighted these two cities, Barcelos and Tefé, because in the last 2 years, you have been seeing in these two cities high drought and a very, very sad drought that make the riverines be integrated in the list of food and water insecurity. So it's very sad situation, and all our work showed this before. So when does it start? So uh, last month you could see some dates from the Copernicus and some dates about climate. In 2023, we saw this very, very famous graphic that shows us to the daily global surface air temperature anomaly. And you have a record here in November of 2023. So this was so scared because we are seeing this the first time in our history. And as you know, the last year, 2024, was the first year that we crossed the limit of 1.0 Celsius degree. So we are in a very bad situation. We crossed the limit considered safe to us. And so we don't know what will happen with Paris Agreement in this scenario, but we are achieving in this scenario that tipping point that I showed to you in the beginning, especially in the colder uh, ecosystem. So because of this, we show some forecasts, some scenarios, and people say, okay, but this will happen when you achieve 2 Celsius degree. But we are seeing now the loss of ice in many places in the pole, in south, in north, etc. And you have a big problem today because scenarios of climate created by scientists, uh, some things that we thought for the 1 or 2 decades ahead is happening now. So we are in a moment that we don't know what will happen with us and with the ecosystem. So here another example of the most surface air temperature anomalies by latitudes. So here, where of most parts of you are now, the middle latitudes, you can see in 2023 and 2024, you had anomaly, a high, very high anomaly of temperature in the land, temperature in the ocean, and very similar in the all parts, but especially in the tropics, where you have anomaly very high of land in the land temperature, but especially in the temperature in the ocean. So this started. Here, example of the anomalies, the temperature in the ocean in 2024, here especially in the Atlantic Ocean, that is around Brazil. So this influences directly the humidity that enters in the Amazon. So the globe, the Earth is a system, is a global system. So these things, you have a cascade effect. And now we have been trying to deal with this new situation. So in the Amazon, this is a very good graph because you have here in this axis the years since 1951 until 2017. So you have some behavior of the dry season. When you have extreme drought, you have the extension of this dry season. So these have happening more intense and frequent. So please note that you had a drought since 91st. You had drought in 1983, 1987, and then 1998. So in the last decade, 2 decades, you have been drought more frequently. And the problem is, I told you about the functioning of some trees in the Amazon, and these trees can have problem when you have or an intense drought or this so extend dry season. So in 2010, you had a dry season start in the March the middle of March, and ended in September, in the end of September. Now you have this very common start in April and now end in October. So this extension here that I have been living is very, very problematic for the functioning of forest in the Amazon. And this started. There's another study from a colleague, Luciana Gatt, a colleague from the National Institute for Space Research in Brazil, and she worked flying across the Amazon to quantify some gas. And she found that in many places, in three or four places in the Amazon, you have a very problematic scenario because you have an increase in deforestation in all these places, decreasing in precipitation, in the same time, an increase in the temperature. And disease affects the carbon balance. So in red bar is the total flux of carbon. The red one is the flux emitted by fires, and the blue one is the emission, the total emission resulted from this difference in the Amazon. And this study showed that the Amazon today, in some places, especially in this arc of deforestation, here the area of the stable forest, we are emit carbon more than absorb. So just to show that in last year in the Amazon, you have almost 70% of the municipalities in the high risk of drought. And here to show that another problem with these changes, that is the mortality of wet climate tree species in areas where the length of the dry season is increasing. So that graph that I showed to you to show the length of dry season, in this region, what we are seeing, the change in the temperature, the humidity, and the rainfall pattern are dying the trees are more adapted to wet climate. And so we are saw not an invasion, but surviving, replaced by species more adapted to the new climate, more dry, more with high temperature. So this is happening in the Amazon. So I need to talk about the biodiversity in this scenario because of this here. In this region, that is the arc of deforestation, you have homogenization of the landscape. So you have less diversity of biodiversity, diversity of tree. You have the advance of pasture, of agriculture, agribusiness, soybean, eucalyptus in some places, but many wood species. So you have a homogenization in this place, and this is one of results. The more adapted species are dominated the landscape. So you need to understand the importance of biodiversity in this context because biological diversity is directly related to resilience of forests. Why? the diversity of functional groups and the diversity of species within these groups can create a high diversity of response to climate change, to deforestation, etc. So when you have a very diversity landscape, you have this concept here that is very important to you, a diversity of response there is among species that contribute to the same ecosystem function, provides adaptive capacity in a world of complex systems and uncertainties. So if you have a landscape where the climate is changed or you have another uh, kind of disturbances such as the pattern of rainfall, etc. When you have a very diversity of species, these species can adapt in a different way in this situation. But when you have landscape so homogeneous, you can lose this capability to respond to the climate change and other disturbance, including the tipping point. So there you have a problem with this landscape today in that place, and you can see the results. So this is so important, but who protects the forests today in the Amazon? I will show you a video. Please try to identify the territories of indigenous. So here you can see for here two big territories, indigenous territories. Here are small territories, but you can see the difference in a very in a territory with very intense agrarian fights and pressure of deforestation and pressure of wildfires, fights with indigenous people that try to maintain that territory. But it's evident here the limit of the indigenous territory is a very important mechanism to protect the Amazon forest. So again, another place. So you can see here another indigenous land in the arc of deforestation, in a very intense activity of deforestation. And the last one, an example of the park indigenous park of Xingu is a very, very hard place to protect nature. So all these examples in the arc of deforestation, in the area where we are seeing the tipping point happening, and I didn't put the polygon of the indigenous land because I tried to show you the difference inside and outside of an indigenous territory. So some date. The indigenous population in the Amazon basin totals more than 2 million people, so you have many indigenous here in the Amazon. These people are distributed in more than 400 different peoples. And the Brazilian Amazon is home to 305 of these indigenous peoples, and they speak in more than 160 different languages. So you have a cultural diversity, fantastic. Only 3% of all Amazon deforestation has occurred on indigenous land in the last 3 years, but it's number that has rising again. And indigenous territories in Latin America store more than 34% of the carbon stored in the region. But uh, how we can take care of this population? Um, uh, More than 1,200 cases of invasions in indigenous lands happening in 2021. 176 indigenous people murdered between 2019 and 2022. 144 cases of suicide among Yanomami indigenous people between 2021 and 2023. 232 million hectares under pressure for illegal mining. This was mapped by an initiative called HASG in the South America. And you had a very sad situation, the Yanomami case in Brazil, in Roraima. You had identified more than 20,000 illegal miners inside this Yanomami's territory in 2023. 56% of Yanomami children suffer from the chronic malnutrition. And in 2023, we saw a humanitarian crisis by the Yanomami people that resulted in the death of more than 420 indigenous people, and most of them from malaria, respiratory infections, and malnutrition. Malnutrition in the forest where these people depends of forest to survive. So 65% of the victims being children under 1 year old. So in this scenario, what to expect from the professionals in the forest sector in this new reality? So this last one slide, I think. So guys, be aware that forests have a ecological, climatic, and very important, social function. Thinking about forests for the future, please, you have many universities across the world where students are studying one or two species only and listening about the planting and about only 2 or 3 species. This is very sad because we are not preparing the new professionals in forestry sector to the challenges of the future. So please pay attention, particular attention to diversity of response. That concept, very important concept, where when you have a very diverse forest, you have a resilient forest. So please attention on it in forest management, planning, and ecosystem restoration. And please understand the political context and the act to protect forest. So this is all. Thank you so much, guys.
Thank you, Natalia. That was amazing. I want to cry, but it's amazing. It's really important to listen all this information and to know how we are passing Brazil. And now we can open to questions if you have some questions.
Okay, I tried, don't create doubts in the presentation.
Yeah, it was really clear, but I have a question because it's in my mind with the experience in the Brazil restoration and the um, for the enterprise and corporations that has that have made the restoration, the Amazon forestry or in the Cerrado or Mata Atlântica, and I want to know. You think this corporation that do all this restoration, they are really working um, for decrease the impact of the devastation, or it's just a greenwash in the majority?
Yes, yes, this is a big problem, Felipe, because the carbon speech is dominated all the subjects about forests, especially the forest restoration. So it's very common, for example, today in Brazil, we have a mechanism that some public forests, such as protected areas, in some areas of forest that we don't have a designation from the state, but we don't have a designation to the protected areas, etc. And now you have a concession from the private initiatives for restoration, only for restoration. And the guys are trying to put in these protected areas eucalyptus, for example, or pines, for example. And this is very sad because all the time the government is saying, okay, if you have a protected area, it's because you will try to protect that ecosystem. You can't put exotic species. And this is very common in the Atlantic forest because you have this speech, okay, to pay for the restoration, you need to have, again, uh, besides the ecological gains, but you need to pay for the restoration, so you try to carbon market, etc. Okay, is a very good alternative because it's not easy, it's not cheap to restore. But the problem is we are created a very poor forest, restored, and not resilient to the new climate that you have, that you live in. And you have another problem that in many places in the Amazon, in this area where we are living the tipping point, that all initiatives of restoration is not working. So we are losing around 80 or 30% of the area restored because we don't have a good climate, a good soil, and rain to maintain the restoration. So today we are in all the country, in Brazil as a whole, you have a problem with this changing climate that has influence our initiatives of restoration. So you need to act now to create a more resilient ecosystem.
Okay. Yeah. Okay. If we have some other questions. So I think it's clear for everyone.
No problem, Felipe. I thank you for and the IFSA for the invitation. I think there is a very important students across the world need to know.
Yes.
And today we're talking about Amazon, but as you know, you have many risks of tipping point across the world. And I believe that young people has a key role in this contest because you don't have fear and you have disponibility, you have dreams, you want to change the world, I hope. So you have a very key role in this moment, and invite you to try to organize to participate in the next COP, the next COP 30 that will be in Belém, because you'll be the first COP in the Amazon, and you have many problems of infrastructure, etc. But this shock with this reality is very important to thinking about solution, and you need to transform this space, this political space where have been dominated by petrol, oil, gas, etc. You need to transform this space in a space for society, and the young group, young people need to take advantage of this place and have voice to believe and to create a new future, new forest, resilient forest, biodiversity forest, and help to respect and protect traditional people. Okay,
Perfect. Thank you. Yeah, thank you, Natalia. It was amazing, and thank you. Obrigado. Obrigado.
obrigada. Bye bye, guys.
Bye. Ciao.
Ciao.
Je ferme le webinaire. Bonne soirée. Je
Parfait.
transmets
Bonne
la
soirée.
captation demain. Voilà. Donc, et je vous donne rendez-vous mardi soir.
Oui, c'est ça, exactement. Mardi soir.
Le dernier. Et n'oubliez pas de vous inscrire pour le 12 si vous êtes sur Nancy. Voilà.
Bonne soirée.
Bonne
Parfait. Bonne
soirée.
soirée. Ciao.